In this video, we are going to look at the difference between the valence electrons and the core electrons of an element. The valence electrons of an element, or the valence shell electrons of an element, are the electrons in the outermost shell. And a shell is just the energy level. So they're the electrons in the outermost energy level, which means they are the furthest away from the nucleus. And they are going to feel that pull a lot less than the electrons that are closer to the nucleus. So it's going to be easier to remove those electrons than other electrons in the element. So for that reason, these are the electrons that are going to be involved in the chemical reactions. Now, RXN is just an abbreviation for reactions. All right, so these are the electrons that are involved in chemical reactions. The core electrons are essentially everything that is not a valence electron. So the core electrons are the inner electrons that make up the beginning of an element's electron configuration. So they make up the beginning of an element electron configuration. So they are going to be the electrons that are closer to the nucleus. So these electrons are not involved in chemical reactions. So let's look at an example and how we can identify and differentiate between the core electrons and the valence electrons. If you recall, the electron configuration of magnesium is 1s2, 2s2, 3p, sorry, I totally skipped an energy level. That wouldn't happen. 2p6, 3s2. So if I want to identify which of these electrons are the valence electrons, then I would find the number that is highest for the energy level. Remember, the big number out in front represents the energy level. So I'm going to look at the 3 and see all of my electrons that are in the third energy level. And these are my valence electrons. So for magnesium, since I only have 2 electrons in the 3s orbital, then that tells me that I only have 2 valence electrons. All of these other electrons that are not the valence electrons, these are our core electrons. So for magnesium, I have 2 electrons in the 1s, 2 electrons in the 2s, and 6 electrons in the 2p for a total of 10 core electrons. So for magnesium, we have 10 core electrons that are not participating in chemistry and 2 valence electrons that will participate in the chemistry. Let's draw a little diagram with the energy levels of magnesium to represent this a little more. So magnesium uses a total of 3 energy levels. So I'm going to represent that by drawing 3 circles. So my inner circle is going to represent the first energy level. It is going to be closest to the nucleus right here in the middle. The second circle is the second energy level, and the third circle is the third energy level. Now, in my first energy level, I have a total of 2 electrons. Remember, there can only ever be 2 electrons in the first energy level because there's only one s orbital. So in the first energy level, you only put 2 electrons. In every other energy level for this class only, we will put 8. So in my second energy level, I'm going to draw 8. So these represent my core electrons. Now, am I going to put 8 electrons in my next energy level? No. Yeah, you're right. No. We can't put 8 electrons because there's only 2 electrons there. So if I draw those 2 electrons in, these are my valence electrons. Remember, you can only fill as many electrons that the element has access to. Magnesium only has 12 electrons. The blue electrons are the core electrons. I drew 10 of them. So I can only draw 2 more in my third energy level. So here we can see that I have 2 valence electrons for magnesium. So let's look at the periodic table. This periodic table is not in your notes. I find that it does not print well in black and white. Also in color, sometimes it doesn't print well at all either. So when you look at the periodic table, you can just grab any periodic table that you have access to. The groups are the columns and the periods are the rows. So here are all of our periods, and they are numbered from 1 to 7 going down the periodic table. Now, the groups are a little bit more confusing when you're first learning the periodic table because notice we have 3 different numbers. And it looks like this periodic table actually has a typo. That should be 2. So there are 3 different ways to number these periodic tables, these groups on the periodic table. What I like to do is label them 1 through 8 for the main group 11 elements. Remember, these are my transition metals here. They are not part of the main group elements. So I will just label these with a 1 on group 1, this first group, and a 2 here. I'm going to skip the transition metals because they're not part of our main group elements, and then put a 3, 4, 5, 6, 7, 8. The reason I really like doing this is because this will tell me how many valence electrons each one of these elements in these groups have. We just did magnesium. It is in group 2. And we figured out that it has 2 valence electrons. Let's look at one more example. Let's look at fluorine. So fluorine is in the second period, so it's going to have 2 energy levels. So I'm going to draw those energy levels. I'm going to represent them as circles. Remember these energy levels when you're drawing them like this? These are energy levels. These do not represent the orbitals. So here's my nucleus for fluorine. Wow, that is a strange looking nucleus. There we go. Now, if I draw my electrons for fluorine in my first energy level, remember how many electrons can we have? Exactly. We can only have 2. Now, when I look at fluorine, I can find it on my periodic table. I can look at the atomic number to figure out how many electrons we need. Remember, the atomic number tells you how many protons you have. And then you can figure out how many electrons you have based on your charge. Now, fluorine doesn't have a charge. I have 9 protons, which means I must have 9 electrons. If I already put 2 in my first energy level, that must mean I have to put 7 in my next energy level to give me a total of 9 electrons. Now, how many electrons did I write in my outermost filled energy level? 7. So fluorine is going to have 7 valence electrons. Hold up. Which group is it in? You got it. Group 7. It has 7 valence electrons. So if you number your periodic table groups like this, it makes it very easy to determine how many valence electrons each element has in the main group. Don't worry about the valence electrons in the transition metals. Don't worry about the valence electrons in the lanthanides and actinides. We're not going to look at that for this class, only the main group elements.